Alright guys, welcome to your composite area tutorial video. This video is designed to help you guide you through the foldable if you missed it yesterday, and to show you some practice example problems before you go off and start solving problems on your own. For those of you that were here yesterday and you got all the information inside the foldable, you can skip through this part and go straight to the example problems and work those out and watch that part of the video. Otherwise, if you missed something yesterday or you were not here yesterday, then you want to make sure that you stay through this recorded part and watch the video in its entirety. Alright, so the first page you should have should say composite area. This is your foldable. It looks like this on the back side. Okay, so the foldable is just really going to guide you as to how it is that we solve the areas of composite figures. So this is a composite figure, and when you look at this, you want to look at this figure and see, okay, how have they put this figure together? So you're going to break this figure up into shapes that you recognize. So right here, I see a triangle. Here, I see a rectangle, and the last piece we have will be considered a semicircle. Okay, so if at any point during this video you miss something, you want to pause, rewind, go back and catch it again. So we've broken up our figure into a triangle, a rectangle, and a semicircle. So if we had to describe how we would solve for the area of this composite figure, well, it's been made up of three shapes. So we will find the area of each shape and add them together. Okay, so because this figure has been made up of a triangle, a rectangle, and a semicircle, I will find the area of each one and then add it back up to get the area of my whole figure. Okay, so you can use your formula charts to help you find the area of each figure. Note that because it's a combination of all of these, we're going to have to add. Okay, so we're going to find the sum of the areas. So when you're doing this, you need to identify the shape, then practice your FSA method. So formula, substitute, I'm just going to say sub, and then answer. So I'm going to start off with the triangle. Area of a triangle I know is 1/2 base times my height. So the base of my triangle extends from here to here. So I'm going to count 1, 2, 3, 4. The base of my triangle will be 4 units. The height of my triangle extends from here to here. So I'm going to count 1, 2, 3. And that will be 3 units. And then now I'm ready to answer. So I'm going to say 1/2, 4 times 3 is 12. And half of 12 I know is 6. Since they did not specify what I'm measuring in, I must say 6 units squared because I am talking about area. Okay, 6 units squared because I'm talking about area. So now I'm going to go ahead and solve it for my rectangle. So identify the shape. So rectangle. Area of a rectangle says I need to do base times my height. This is the base of my rectangle. That's where it sits. So I'm going to count 1, 2, 3, 4, 5. So the base of my rectangle is 5. The height of my rectangle, that's it going straight up and down. 1, 2, 3, 4, 5, 6. And now I'm ready to answer. 5 times 6 is 30. And once again, units squared. Because we're talking about area. So I found my triangle. I found my rectangle. Now I need to go back and find this semicircle. So the semicircle is half of a circle. So I'm going to take the information for a circle and then divide it by 2, because a semicircle is half of a circle. So I know area of a circle is pi times my radius squared, but I only need half of it, so I'm going to end up dividing by 2. Okay, so plug in pi, my radius, this represents the diameter, so the radius I'm only going to go in halfway, so 1, 2, 3. And now I'm just going to keep working it out. 3 squared I know is 9. Nine times pi, which you must take as 3.14. 9 times pi, or 9 times 3.14, comes out to be 28.26. And then I need to divide that in half. So divide it by 2, and we get 14.13. I'm just going to write U for units squared. Okay? So I have the area of my triangle, which is here. Area of my rectangle, which is here. And the area of my semicircle, which is here. Now I need to go back and add all of them together. So I'm just going to do that down here at the bottom since I kind of ran out of space. I'm going to add all of them together to get the area of the entire figure. Okay? So I'm just going to start with the rectangle because it's the largest. And then my semicircle. And then my triangle. Okay, so remember when we add, you need to line up your decimals. So bring the decimal straight down. 0 plus 3 plus 0 is 3. 0 plus 1 plus 0 is 1. 0 plus 4 plus 6 is 10. 3 plus 1 plus 1 is 5. So I find that the area of this entire composite figure right here comes out to be 50.13 units squared. So remember your units. I will take off if you don't have units. Okay? So 50.13 units squared. So this is a composite figure in which we had to add. So now there'll be some figures in which you'll have to subtract. Figures such as those will appear like this. So when you get figures like this where it looks like something is missing, or figures where they ask you to find the shaded region, that's how you know that you're going to have to subtract. Okay, so anytime they ask you for the shaded region, or it looks like there's a missing piece, we're going to have to subtract. So what you want to do is, in order to find the area of the shaded region here, I need to find the area of the circle, because I have a circle, and once I do that, I am going to subtract it from the area of the square. Okay? So find the area of the circle and subtract from the area of the square. Let me pull this down a little bit closer so you have a better view. Okay? So now we need to find the difference in the areas. So I'm going to calculate the area of my square first. So this is the square. Area of a square says I do my side squared, which simply means side times side. So I'm going to go and count the side of my square. So I'll just start here and go 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 units. It's a square, so the other side will also be 8 units. And 8 times 8 I know is 64. So the area of my square is 64 units squared. Oh, sorry. Couldn't see that. Okay, now I need to find the area of my circle, because that's the other shape I have it here, a circle. So area of a circle, area equals pi times radius squared. I have a full circle this time, so there's no need for me to split it in half. So now I need to plug in, substitute. So I started with my formula. Now I need to substitute pi. My radius, so if this is the center, go halfway, 1, 2, 3, 4. My radius is 4. 4 squared I know is 16. Pi now becomes 3.14. So do the calculation. 3.14 times 16 should give us 50.26 units squared. Alright, so now that I have the area of my two shapes, I am going to subtract the two and place the larger value on top. So the area of my square, and I'm going to take the area of my circle away from that. Remember, decimals line up. I'm going to borrow. 10 minus 6 is 4. 9 minus 2 is 7. That's 3, 1. And we get that the area of the shaded region comes out to be 13.74 units squared. So when dealing with composite figures, you are either going to have to add. So if the figures have looked like they've been put together by shapes that you recognize, we will add. And if it asks you for a shaded region, or it appears as if something is missing, that's when you will subtract. Alright, so the next sheet of paper I want you to look at will be the composite area calculations. I am going to do some guided examples from here. So question number 2. I have this figure here. This figure looks like it's been made up of a rectangle and a triangle. So identify your shapes. So I have a rectangle and a triangle. Okay, so for this one we're going to have to calculate the area of each and add. So it's a rectangle plus a triangle put together. So in your work area here, remember you're going to find the area of each figure first. So I'm going to do the rectangle first. Area of the rectangle I know is base times height. So I start off with my formula. Now I need to substitute for my base and my height. Well, the base of my rectangle is 3. The height of my rectangle is 1. So 3 times 1 I know is 3. So my rectangle is going to be 3 feet squared. Now I need to find the area of my triangle. So identify the shape. Start off with your formula. 1/2 base times height. And now we substitute. my base, so the base of my triangle, when you need to identify your base, you are looking for, if your figure was to be sitting, where would it, how would it sit, what would it sit on? So if my triangle was sitting, it would sit right here. So the base of my triangle is here, and it's the same measurement as the height of my rectangle. So my base of my triangle will be 1. The height of my triangle, okay, remember height goes straight up and down, and it connects with your base, so it kind of makes an L shape. So the height also tells me is 1. So now I'm ready to answer. So half, 1 times 1 is 1, and half of 1 I know is 0.5. So now that I have the area of both, I need to add them together. So 3 plus 0.5. Line up your decimals. 5, 3. So the area of that composite figure is 3.5 feet squared. Make sure you identify your final answer by boxing it in. Okay, so this is the process you're going to have to use for all these problems. You need to identify the shapes that make it up, find the area of each one, and then add or subtract according to what your figure is. Alright? Example 3. I have a square and a semicircle. So this figure is made up of a square plus half of a circle, or you could say a semicircle. So when I'm doing my calculations, I need to find the area of a square, and I'm going to find the area of a circle and take half of it. So let's start with the square. So identify the shape. It's a square. Area of a square is my side squared, which simply means my side times side. My side measures 10 meters. 10 times 10 I know is 100. So the area of my square is 100 meters squared. Now I need to find my half a circle, or your semicircle. So that means I'm going to take the area of a circle and divide it by 2, because I need half of it. So that's my formula. I substitute pi, my radius, start at your diameter, count out, so you should have 1, 2, 3, 4, 5. Five squared I know is 25. Pi now becomes 3.14. So I need to do 3.14 times 25 and divide it by 2. If you need more room, you're more than welcome to grab some scratch paper and show your work there, or if not, go to the side in here and show your work there. But I know 3.14 times 25 is 78.5. And now I'm going to divide that by 2. So I take half of it, and I get 39.25 meters squared. So now that I have the area of my two shapes, I'm going to combine them because we said that we needed to add. So 100 plus 39.25. Remember to line up your decimals. 25.931. So the area of the entire shape comes out to be 139.25 meters squared. Do not forget your units. Alright? And finally, the last example we'll look at, on the back side, example 6. So for example 6, I'm looking at this figure, and I notice that it's in the shape of a rectangle. So I'm going to use a rectangle. But then it looks like 2 semicircles are missing. So I'm going to say minus 2 half circles. Well, I know that 2 half circles make a whole circle, so I'm just going to turn my 2 half circles into 1 whole circle. So to find this, I'm going to do a rectangle minus a circle. Okay? 2 half circles, 2 semicircles make up a whole circle. So I can rewrite this and say rectangle minus a circle. So I'm going to come find the area of my rectangle. So identify the shape. Area of a rectangle, we know is base times height. So that's my formula. Now I need to substitute. Well, my base, according to the diagram, is 28 inches. My height, remember straight up and down, makes an L shape with your base, is 15. So I need to work out 28 times 15. So be sure to show your work. 28 times 15 I know is 420. Now I need to find my circle. I'm only going to find one because I combined my 2 semicircles together. 2 halves make a whole, so 2 semicircles make 1 whole circle. My formula is pi times my radius squared. Now I'm ready to substitute. Radius, so it gives me my diameter is 15. So to find my radius, I have to take my diameter and divide it by 2. So that means my radius is going to be 15 divided by 2. And 15 divided by 2 is 7.5. Okay? So here's what I calculated for my radius. Radius is diameter in half. Diameter is 15, so half of 15 is 7.5. So I'm going to say 7.5 squared. 7.5 squared means you need to work out and do 7.5 times 7.5, which should come out to be 56.25. Pi now turns into 3.14. So you need to go off in here somewhere on a separate sheet of paper, which is fine, and multiply 3.14 times 56.25 and you should get 176.625. I forgot my units. Inches squared. Inches squared. Okay, so now that I have the area of my rectangle and the area of my circle, we said we needed to subtract. So I'm going to take the rectangle 420 and subtract 176.625. Remember to line up your decimals when you're adding or subtracting. So decimals line up. I have to go borrow. And I'm going to keep carrying this over till I get it to where I need it to be. 10 minus 5 is 5. 9 minus 2, 7. 9 minus 6, 3. 9 minus 6 again, 3. 1 minus 7, I can't do that, so I'm going to go borrow. 11 minus 7 is 4. 3 minus 1 is 2. So the area comes out to be 243.375 and my units are inches squared. Alright? So that is the amount of work you're going to have to put into solving these. Be careful with your decimals. Make sure that when you are multiplying, you line up your numbers. When you are adding, you line up the decimals. When you're subtracting, you line up the decimals. Okay, so you can review this video, rewind, repeat as often as you need to. So we have completed example 2, example 3, or I should say problem number 2, problem number 3, and problem number 6. So you are responsible for completing the rest of this sheet. So 1, 4, and 5. Then when you're done with that, you will move on to composite area combo and only complete the front side. So problems 1, problem 2, and problem number 3. So you will only do the front side of composite area combo. Calculations, you will finish up the rest. So any problems that you haven't completed, you will finish that up on composite area calculations, front and back. So by the end of this, the whole worksheet should be completed. And then you will do only the front page of composite area combo. So problems 1, problem number 2, and problem number 3. All right, have fun.